Okay, so in our last video, Dave went through some of the history and some of the great uses that we could touch on with semantics, but let's talk about why would an enterprise go and use semantic technology? It's great to put together web pages and searches and things, but what else can we really do with this technology? We talked about integrating diverse data sources already, but this is really meant to illustrate where you can take completely disparate concepts from one system to another and relate them using a similar language or the same language so that you can do apples to oranges comparisons when it makes sense. But if you have two systems where the same concept is represented in two relational databases with different table structures, but it's both, let's say, people, or in this case oranges, you can look at an orange in one system and look at an orange in the other and be able to treat them the same using semantics and federation. And that allows you to treat an orange as an orange no matter which system it comes from, whether it's in 1 or 15. Federation and integration in real time means that you don't have to go through what we've traditionally done in the past, which is when you have a relational system and another relational system and another relational system, and you want the data out of all of those, you're going to run some sort of ETL process, pull all of that into a data warehouse, and then write custom reports and new tables, and then if the structure of any of them change, you've got to rewrite your data warehouse. The carnage that data warehousing has created in terms of failed projects is well documented, and it's something that a lot of developers and designers have really suffered through over the years. Semantic is a way to help address that issue and give you the option to dynamically federate these things. So instead of pulling everything into a data warehouse, you can actually speak to each relational system as it exists today without having to change its structure or without having to do an ETL process. So supporting those multiple logical data models without ETL and warehouses affords you the possibility of slicing and dicing your data and stacking it into this new virtual environment and being able to use semantics to leverage when an orange is an orange, or when you want to compare an orange to an apple, or if you need to put those two things together so that if you have the concept of relationships between people in one database and the people themselves, or possibly where they work in another, or places, or any of those things, you can stitch all that together using the power of semantics and inference in order to pull all these things together in new and exciting ways. So being able to do that means that you can then infer or derive relationships from one database to another without having to fully enforce those. Because the other issue that we have is often data is spotty, missing, sometimes inaccurate, and semantics flexibility really affords you the possibility of being able to deal with those ambiguities without the rigidity that comes with a relational database, which is often involves optional relationships, optional columns, you have to deal with that in queries, things like that. Semantics helps abstract some of that complexity out. Analytics is a huge, huge source of power for businesses in today's world, and semantics helps augment those analytics. Dave touched on it a little bit, being able to run analytics against your data in real time, being able to try things out, see what's real, what isn't, which relationships are stronger, more correlated. All of the things that really give analytics its power become somewhat easier when you can look at your data across the federation without going through some huge process to pull it all together first. We've talked about big data a little bit. I want to delve into the definitions that we're using. I've seen on the internet there's a lot of definitions for big data, so I'm going to standardize the one that we're talking about. We're talking about 4 V's. We're talking about volume, velocity, variability, and variety. Okay, volume is just the amount of data that you have to store. Velocity is the amount of data that's arriving to your system or systems and how fast and how big it is. So basically, how big is your pipe? Variability deals with how often does that data change, and then variety is how often do you have to introduce new sources of data, new websites, new government sources, new reports, any of that stuff deals with variety. Triple stores do really well with volume and velocity. The commercial products can scale up to billions of triples now. Directed graphs directly address the variability issue because there's no defined structure that you have to live with. You can deal with variability in a very, very real-time sense, and that also helps you deal with variety. So if you get new sources of data, you can incorporate the parts that you understand, and the complex ones that maybe aren't fully understood or are too sparse for you to make analytic decisions on can be pushed off till later. The concept of URIs also lets you deal with variety, meaning that with a URI, you can have the concept of an orange from one source, the concept of an orange from another source. But because we put a URI on the front, we can name them the same thing, but still have those be distinct and understand where they came from.